Hello everyone, welcome to lesson 5 for AB Calc. This is the intermediate value theorem lesson. I want to say that this is the first theorem of quite a few that we're going to learn in this class. It is a pretty straightforward theorem if you kind of understand the logistics of it. So I'm going to go ahead and tell you guys the idea behind the theorem, and then we're going to do a couple problems and just make sure that it solidifies the knowledge that you guys need. So the intermediate value theorem, this is a good example, is if you're driving on the road and you're traveling 40 miles per hour. So just imagine you're on the road driving 40 miles per hour, and then a minute later you look at your speedometer and you see that now you're at 50 miles per hour. All the intermediate value theorem is basically saying is that this is a continuous function, right? You're driving continuously, so you go 40, 41, 42. There had to be some time, we're going to call that time C. We don't know exactly when that C is, but there's some time within that minute that you had to go 41 miles per hour. Right, in order to go from 40 miles per hour to 50 miles per hour, you had to go through 41, 41.5, 43 miles per hour, 47 miles per hour. You had to do that. So every possible value between 40 miles per hour and 50 miles per hour. And the reason why is because it's a continuous function, right? You can't drive and go from 43 miles per hour to 47 miles per hour without going through 44, 45, and 46. So that's the idea behind the intermediate value theorem. Let's go and look at another point of the example. So here in this example right here, I've got a function that's I need to fill in, and so it's going to go through the point 1, 3, and it's going to go through the point 5, 9. I'm also telling you that this function f of x, is also going to be continuous on this interval. All right, so it's going to be continuous on the interval from 1 to 5. So what I want you guys to do here is just visualize I can draw a many different ways to connect these 2 points, right? So I want a function that is continuous between 1 through 5. So I could draw a line that goes straight like this. That's a kind of boring function to do, but it's still a function. I could go and do a function that goes like this, crazy like this, also a function. And I'm just going to just be, or I could do something like this. And I'm going to stick with this function right here. All right, I'm going to stick with this function right here. So all the IVT theorem says is this. So I'm on the interval from 1 to 5. All right, so I'm on that interval, so I'm only going to be looking at the x values from 1 to 5. And so what the IVT says is that there has to be some value C. There has to be some value C that if I were to go and put a point here, C, it's got to hit the values between 3, our lowest value, and it's got to hit the values of 9. Now, it can go above and below, but I have to have a point where it hits 4. There's got to be a point where y equals 5. There's a point where y equals 6, 7, and 8 to 9. So how I use this analogy with my students, I said, this is a house. This is a house that we're living in. And so we can't go out of the walls, but we can go downstairs. So we can go below 3, and we can go upstairs above 9. So we can go in and out of the floors, but we have to stay within the house. But all IVT says, and when I show you guys the first example, hopefully this will make more sense. But in order for me to go from this point here to this point here, y has to be between 3 and 9. I have to go 4. I have to hit 5. I have to hit 5.5. I have to hit 7, 7.3, 7.4, etc. to 9. That's all IVT says. So let's look at an example and see if that kind of makes sense to you. Okay, so the formal definition for the intermediate value theorem, and by the way, I should mention that we are going to call this IVT, and it's totally fine for you guys to call it IVT as well. So the intermediate value theorem, it says f is continuous on the closed interval. And so I'm going to stop there for a second because our key points, there's 2 key points that you need to know. Guys, you cannot apply the intermediate value theorem unless the function is continuous on that given interval. Okay, it's got to be on the given interval, and we will give you guys the interval for that. So it's got to be continuous on the interval. That's really important. So f of a cannot equal f of b. We have to go from one point to another, right? We have to travel up or down the y-axis to one point or another. Number d between f of a and f of b, there must exist some value c between a and b such that f of c equals d. So that really, for some students, just doesn't make any sense. So I'm going to actually, when I do the first example, I'm going to rewrite it. I'm going to show you guys how to justify your answer using IVT, and then we can come back up here and kind of explain this a little bit more, because that right now, initially, without doing a problem, that may make no sense to you, but it will, hopefully. The other thing is that IVT proves a value C must exist, And again, this will make more sense when I actually give you guys a problem, but not necessarily the value of c. All right, so again, we're going to talk about this a little bit more. So let's actually do an actual problem. So example number 1 on your notes says, given that f of x is equal to this cubic function, prove that f of x has a root on the interval from -1 to 2. So -1 to 2. So basically, we're not going to graph the function, but what this is saying is that I got to figure out where my function is defined at -1, where my function is defined at +2. So that's the first thing we want to do. And what I'm doing here is I want to try to find what f1 is, and I want to find, or sorry, -1, and what f of 2 is. So that, ladies and gentlemen, is going to be the f of a and the f of b. All right, so that's what we're going to do first. We're going to find f of a and f of b, and that's what you will always do first. So let's do that. So looking at the example, we're going to look at f of -1, and so we're going to plug -1 into our function, and then we're going to evaluate that value. And to save us some time, this value is 8. So trust me on that. All right, it's 8. So what this means is that at f equals -1, my y value, my corresponding y value, is at actually 8. So I'm going to have a continuous function that's going to come out of this point, and so I want to go to 2. What the question's basically asking us and telling us is going to happen is that once I get the y value of 2, I'm going to cross the x-axis at some value here, right? It's asking us to prove that we have a root. So let's go ahead and find now f of 2. And again, just like before, we're going to plug in 2 to our function. And again, to save a little bit of time, I'm going to go ahead and just say that this is actually equal to -19. So then all the way down here, we're at -19. So again, IVT says that I need to connect these 2 points. I have to connect these points. Again, it doesn't matter how I connect the 2 points, all right? I just know that at some point, some value of c, I don't know what that value of c is, but I know in order for me to go from point A to point B on a continuous function, I have to go through the x-axis because one of my values is positive and one of my values is negative. You can also think about if I ask you guys to stand on the number line, this is kind of be weird, but if I ask you guys to stand on the number line at -19 and I want you to walk to 8, you have to cross 0. As a matter of fact, you have to cross every y value between -19 and 8. So this didn't even have to say root. It could say f of c is equal to 5. And that's also true because I have to find some value of c where I'm hitting y at y equals 5. So again, hopefully that's making sense. So let's actually write out the justification. I apologize that this is actually the most tedious justification that you're going to be doing, but you still need to learn it. So here's what you're going to say. So I'm going to say since, and so I'm looking at f of 2. F of 2 is equal to -19. All right, so since that is less than our value that we have here, so 0, right? A root means that y is equal to 0. This would be where y equals 0, which is less than f of -1 is equal to 8. So what this is saying is that I have this value y, 0, between -19 and 8. All right, so I now know that it's between these 2 outputs from my left hand of my interval and my right hand of my region. So since this is true, and I'm going to use different colors to highlight different stuff, and f of x is continuous, you have to say that. If the function's not continuous on that interval, then this will not apply. Because I could absolutely draw a line here, open the dot, and then I can go and do a solid dot here, and that means it's not actually going to cross the y-axis. So it's got to be continuous. It's absolutely 100% got to be continuous. So that's really important for you guys to do, or know. All right. Then you always want to justify by what theorem you're using. So, and f of x is continuous by IVT, and you can absolutely write IVT instead of intermediate value theorem, by intermediate value theorem. And then again, hopefully this will make sense to you. There exists a c. Now again, we don't know what that c is, but it's some value between -1 and 2. So on the interval from -1 to 2, such that f of c, the y value at c, has to equal 0, right? It's got to equal 0. Again, if this had said, prove that there was a root of f of c equaling 5, you would say the same thing. You'd say 5 right here. So the only difference between this problem and this would be the fact that there'd be a 5 here. So let's go and look at another example and see what you guys can do. I encourage you guys, if you followed along pretty well, just to go ahead and do example 2 by yourself, pause it, and then come back to the video. But before you do that, just remember, all you're going to do is you're going to plug in your function for f of a and f of b, and then honestly, guys, whatever number they're going to give you here, you're going to have one above it and you're going to have one below it. That's the easiest way for me to explain it to you. So if we go back up here and look at our definition, we have a continuous function. We know that f of a cannot be equal to f of b for any real number d, and so this d is the y value that we're given in the problem. So this d happens to be the 0 that we talked about here, and the d happens to be the 5 that we're given in example number 2. All right, between f of a and f of b, then there must exist some c. We don't know what that c is. So if this is a and this is b, we know that, let's say a starts here, b starts here, and so we have some c that's got to cross, it's got to cross at some value d. All right, and again, if that makes no sense to you, and some people, I've probably lost you right there, then just kind of go through the problem and see if you can make sense of it. So try example 2, and I'm going to come back in a second, and I'm going to show you guys how to do it. Okay, so example number 2, it says, given that g of x is equal to 10 sine of pi x over 4, prove that g of c is equal to 5, okay, for some value c. Again, we don't know where it actually is, but some value c on the interval from -1 to 1. So the first thing we're going to do, and remember this is our a and this is our b, we're going to go ahead and find what f of a is, what f of -1 is. So we have 10 sine of negative pi over 4. Okay, so what we have to understand here is, and again, trig values, we know that the negative pi over 4 puts us in quadrant number 4, and so the sine of pi over 4 is the square root of 2 over 2, and because we're in quadrant number 4, we're negative. You can also think of sine as an odd function, and remember for odd functions, I don't know if you guys remember this, but it's just always to be nice to remember this part of algebra 2, is that you can actually just find the function of f of x and just change its sign. So that's the way for odd functions to work. But anyways, back to this problem. So we're going to go ahead and multiply 10 times the negative square root of 2 over 2, and you're going to get negative 5 over 2. So what we're going to do over here is I'm going to graph, and at -1, I'm down here at y equals negative 5 over 2. Now remember, all the IVT is saying is that this is going to be g of c is equal to 5. So when I find my second point, my f of 1, I need to be somewhere above this line because I need to cross over the line y equals 5, all right, to some value up here. So when I plug in 1, I better get something greater than 5. And that's another little trick that I want to share with you guys for this problem. So f of 1 is going to be equal to 10 sine of pi over 4. Well, that's awesome. We love the first quadrant. I hope you guys do. It's pretty easy, right? So it's just 10 times the square root of 2 over 2. And that's just going to be equal to 5 square roots of 2. And that is bigger than 5, so we're pretty good here. So then we're at 5 square roots of 2. So we've justified our means here that one of them is above 5 and one of them is below 5. So in our nice little song and dance that we have to do for our justification, we're going to name out, since now f of -1 is equal to negative 5 square root of 2, and that's less than 5, okay, so that's below this y value of 5, which is less than f of 1 is equal to 5 square root of 2, all right? So again, that's just saying that this is in between the two y values, and again, f of x is continuous, okay, it's continuous by IVT, okay, by IVT, there exists some value c, and again, we don't know where, we just know that that's the c value is right here. We don't know exactly what it is, and we don't need to know what it is. On the interval from -1 to 1. So again, ladies and gentlemen, it's like our house. We can't go outside of our house because it won't not be a function, but we can go up and down the house, right? So it's got to be between -1 and 1 on the closed interval from -1 to 1, such that, and then you can basically just write what you have right here. There's got to be some value of c that the y put is 5. Okay, so that's going to be video number 1. I'm going to keep it short for you. I'm going to have a second video for you guys to do more examples of this because there's a little bit more diversity when it comes to questions about IVT. But that's the general idea from it. So hopefully that made sense to you guys, and I'll see you in the second video.